Good morning, students. Welcome to the Aryabhatta PU Science College. Now we are going to study the second period of the second chapter, so electrostatic potential and capacitance. So derive an expression for potential energy of 2 points in the absence of external electric field. It comes in model question paper 2021. It is very important question. So, derive an expression for potential energy of 2 point charges. So, A and B are the 2 point charges you see here. In order to know this example, you have to consider one example. In order to know this derivation, you have to take one comedy example. You have to remember this one example, very important example. You have to study. You see. So, suppose school, this is a school, a B point is a school. A school is there, and near that school, on the road of this school, this is a road, and this on the way, there is a shop. Shop is there, and a house is there. This is a house. House is very far away. A house is far away from this. This is especially this is a LKJ UKJ school. This is and this is nearby. There is a shop and one home is there. House is there. We have to bring a small kid from house to the school. So you are already seen in your daily life. That is if to bring a small kid. That is for 3 years or 4 years LKJ UKJ students. It is very difficult to bring the school, bring the kid from house to the school. Kid, suppose one kid is there. Kid means small boy. Small boy. Small boy is there. It is very difficult to bring a boy from house to the there is point B. That is, this is point A to school. What we are doing to bring a school, bring a small boy, from house to the school. What the father is going to do? So he is giving, he is saying, I will give you some chocolates in the shop. Then you come to this school. Like that they are going to say. So if the boy wants the chocolate, so then what he will do? He is in the school and he is not interested in going to school. He is in the house. He is not interested to go school. So what he is doing? But he is very interested in going to shop to take a chocolate or sweets. To eat some chocolates or sweets. He wants the chocolate, but he don't want to go school. So what he will do? From house to shop, he is not giving any objection. He is not crying because after eating this chocolate, then what he will do? He starts crying to go school. After eating the chocolate from in the shop, he is not going to cry. After the eating, he starts crying to go from A to the B. From shop to school, it is very difficult to bring the boy. So that is the fact here. So to bring a boy from house to this shop, no work is done because automatically without any crying, fully with very happy, the boy will come to the point A. So from A to B, from shop to school, it is very difficult to bring that boy because he is not interested in the going to school. So that fact is used in this here. Suppose 2 boys are there. One boy is going to the shop, so that he will eat. To see if the same boy is going to school, then what you will do? Up to the point A, there is no difficulty to bring. From A to B, it takes very difficult. So in the same way, in the same concept we are using here. So, what is deriving expression for potential energy of 2 points in the absence of electric field? That is model question paper 2021. You see, or another type of question may ask, deriving expression for electric potential energy of system of 2-point charges in the absence of electric field. That here, you see, Q1 and Q2 are the two charges. So, say you see Q1, a charge, we have to bring a Q1 charge from infinity to the point A. From infinity to point A, to bring a charge from infinity to point A, no work is done. If we bring a Q1 Q2 charge from infinity to B, from infinity to A, no work is done. To bring a Q2 charge from Q1 to Q2, that is A to B, we have to work done by the Q1 charge. Q1 has to be, it is disturbed by this Q1 charges. So, that is work done due to Q1. Here Q1 charge is there, due to that Q1 charges we have to work done. So, that is, are you following? To bring a Q1 charge from infinity to A, no work is done. In the same way, to bring a Q2 charge from infinity to A, no work is done. Q1 charge is as it is in the A point, and we have to bring a Q2 charge from Q1 to Q2. That is, from A to B, we have to bring it. Then work is done due to Q1. Same point is there. So, same. Consider the following. Q1 and Q2 is equal to 2-point charges. Q1 and Q2 is equal to 2-point charges. Q1 is equal to that is point charges brought from infinity to A. Q1 charges is equal to point charge brought from infinity to point A. Q2 is equal to point charges brought from infinity to point B. Q2 is equal to point charges brought from infinity to point B. So, R is equal to distance between Q1 and Q2. R is equal to distance between Q1 and Q2. And V1 is equal to potential at B due to A, due to Q1. So, it is the potential we have to invest, the energy is needed. Due to Q1, a potential is potential at B. This is the potential, this energy is required to bring from charges from A to B. So, potential at B due to Q1 is equal to V1 is equal to 1 by 4 pi epsilon naught into Q1 by R. So, that is a previous class definition is there. So, potential at a point P is equal to 1 by 4 pi epsilon naught into Q1 by R. So, in the same way, potential at V1, that is V1 due to B, that is potential at B due to Q1 is equal to V1 is equal to 1 by 4 pi epsilon naught into Q1 by R. So, that is potential. And W is equal to work done due to Q1. Due to Q1 we have to work done. Here charges Q1 is there, to bring from the Q2 charges from A to B. What is this? Due to this Q1 is disturbing this Q2. So, it is due to the Q1 we have to work done. So, that is W is equal to work done due to Q1. So, that is it. And point charges. So, point charge Q1 is equal to Q1 brought from infinity to point A is equal to no work done. Point charges charge Q1 brought from infinity to point A, no work done. In the same way, point charges Q2 brought from infinity to the point B is equal to work done due to Q1. So, total work done is equal to potential into charges, potential at Q1, that is Q1 into Q2, V1 into Q2. So, V1 means 1 by 4 pi epsilon naught into Q1 by R into Q2. So, that is 1 by 4 pi epsilon naught into Q1 Q2 by R. So, work done is stored as a potential energy. Potential energy means V is equal to 1 by 4 pi epsilon naught into Q1 Q2 by R. So, this is an expression, very important expression. Once again I am saying, Q1 and Q2 is equal to point charges. Q1 is equal to a point charge brought from infinity to point A. Q2 is equal to point charges brought from infinity to point B. R is equal to distance between Q1 and Q2, or distance between R, A and B. So V1 is equal to V1 is equal to potential at B due to Q1 is equal to V1 is equal to 1 by 4 pi epsilon naught into Q1 by R. So W is equal to work done due to Q1. So point charges Q1 brought from infinity to A is equal to no work done. Point charges Q2 brought from infinity to point B is equal to work done due to Q1 is equal to total work done is equal to potential into charge is equal to V1 into Q2. Q2 is as it is, and V1 is equal to 1 by 4 pi epsilon naught into Q1 by R. So totally work done is stored as a potential energy. So that is V is equal to 1 by 4 pi epsilon naught into Q1 Q2 by R. So this is an expression very important. In the previous, that is in March 14th, in 2014, 2018 and July 16, this question is arises. Only expression we have to write here. Write an expression for potential energy of 2-point charge in the absence of external electric field is here. Same this question we have to write this answer. V is equal to 1 by 4 pi epsilon naught into Q1 Q2 by R. Formula we have to write, and where Q1 and Q2 is equal to point charges, R is equal to distance between Q1 and Q2, epsilon naught is equal to permittivity of free space. So that is, this is without, by seeing one time and without seeing another time, you have to write it in the notes rough, and all this you have to write it in the notes. Next one is define potential difference V. Potential difference means it potential difference or potential is always is in 2 points where there is a 2 points. Potential will not measure in a single point. Potential always is measured in the 2 points. Suppose one example you say, in your house, if the light becomes a single phase, then what is in the, if the light becomes a single phase, what will we can see? So there is a dim light becomes dim, so voltage becomes down. Voltage means the potential between your house and the nearer transformer is that potential difference between the potential difference. Potential difference is the energy between your house and the nearer transformer. In the same way, potential is always represented in 2 points, between the 2 points. So define potential difference. Amount of work done in transferring a charge from one point to another against the direction of electric field is called potential difference. Amount of work done in transferring a charge from one point to another against the direction of the electric field is called potential difference. Amount of work done in transferring a charge from one point to another point against the direction of electric field is called a potential difference. So it is a scalar quantity, it is represented in volts. Write the answer. So it is a very important question, you have to write it here. And another is write the expression for electric potential at a point due to an electric dipole, and hence obtain the expression for the same at any point on its axis and any point on its equatorial plane. This is a very long derivation. So it is not given any year in the examination, so it is not important. Only I have written the there is only expression I have written here, only formula I have written here, you have to take it, write it here. So V is equal to 4 pi epsilon naught into P cos theta by R square. V is equal to 1 by 4 pi epsilon naught into P cos theta by R square, where P is equal to 2AQ is equal to electric dipole moment, R is equal to distance of the point from the center of the dipole, theta is equal to angle between P and R, epsilon naught is equal to permittivity of spaces. So for any point on the dipole axis, theta is equal to 0, cos 0 is equal to 1, p by r square remains, or plus or minus 1 by 4 pi epsilon naught into p by r square. Theta is equal to 0 means theta is also possible for 180 degree. So 180 means theta cos 180 is equal to minus 1, so plus or minus comes here. For any point on the equatorial line, theta is equal to pi by 2, which implies cos theta is equal to 0 and v is equal to 0. Just this question you have to write it. I think it is not important, only just you have to write it. Next, what is an equipotential surface? Give an example. So equipotential, it comes in March 15th on model question paper 2021. It comes here. So what is then equipotential surface means, suppose there is surface of charged conductor. In charged conductor, potential, that is plus charges are always distributed, plus or minus charges are equally distributed. So that is conductor. In the plastic comb, or in the first field what I have shown in the first chapter, in a surface comb, if I rub a comb to the cloths and comb accumulates positive charges. So in the insulator, the charges are not equally distributed. So in the conductors, charges are equally distributed. So that is equipotential surface means means equally, potential means potentials are distributed. So equipotential surface means any surfaces. So equipotential surfaces means surface on which the potential remains same at every point is called equipotential surface. The surface on which the potential remains same at every point is called equipotential surface. The surface on which the potential remains same at every point is called equipotential surface. Example, surface of a charged conductor. Next, what are equipotential surface of a point charge? Here there is a single charges is there. So equipotential surface of this charges, single charges, it is just like a spherical shape. For equipotential surface of a single charge, it becomes a spherical surface. So that is, this is a point charge, the spheres around this charges fully equipotential surface is there. Equipotential surface of a point charge are the concentric spheres with center at the point charge. It is center of the point charge, and around this there is a concentric spheres. So draw the equipotential surface of a point charge. So if plus charge is around this equipotential is there, concentric spheres. Yes. Give the condition for equipotential surface in terms of the direction of electric field. So electric field is perpendicular to the sphere. Here a sphere is there, it is perpendicular in this direction. It is very perpendicular to the electric field. So that is, so there is electric field perpendicular to equipotential surface. So, and equipotential surface means, so equipotential surface of a point charge or the concentric spheres with center at the point charge. Equipotential surface of a point charge or concentric spheres with the center at the point charge. Equipotential surface of a point charge or concentric spheres with center at the point charge. So these one you have to write it. All these you have to take it in a notes, and these important what I have underlined here, that you have to, by seeing one time and without seeing another time, you have to write it in a rough, and definitely these questions will come in the examination. So very important questions you have to take down. Best of luck.